Hello and welcome back for another VMK in the puzzle series. In the previous VMK I introduced you to the 3x3 puzzle called One Tough Puzzle. In this VMK I'll be giving you a hint on how to solve this puzzle if you're having difficulty conceptualizing the real objects into something that the computer can use and actually solve for you. So let's go into Visual Studio and take a look at what I've got here. We know that the solution has to be this 3x3 matrix where we need to figure out what each of these individual pieces are. And at the end of the last VMK I showed you the 9 individual pieces, specifically pointing out what shapes are on each side of each of those pieces. So knowing that we're going to need a 3x3 matrix and that there's 9 pieces to play with, what I'm about to present to you is just the way that I ended up finding the solution to the puzzle. So what I did is I created an STD vector of pieces. So piece is an object, which I'll show you here in a second. And this vector is going to contain all the 9 pieces that I showed you at the end of the last VMK. I also have this array of 9 objects, which I labeled here as the solution. This array is basically going to hold the solution once it's found by the computer. So we have these 2 global variables here. To initialize this vector here of these pieces, inside of the main, I go through and I push back each of those pieces. If you compare what I have here with the previous VMK, you'll notice that I went through one by one each of the pieces, and I basically told you what shapes are on each side. So the way that I've defined the constructor for piece here is I specify the shape, whether it's a spade, a diamond, a heart, or a club, and then I also say whether it's pointing inward or outward. So we need to distinguish that by labeling them like that. So if you basically look at this first line here, line number 17, this is saying that I have a piece that has a spade out, a diamond out, a heart in, and a diamond in shape that comprises that piece. I take that piece and I push it back onto our vector so that now this vector contains that one piece. Then I go through the next one, so all of those 9 pieces are the 9 individual shapes that we need to match up to somehow form this 3x3 grid. So after we have all those pieces in memory, we can then go and write some code here to find the solution that we're looking for. If we do find a solution, we'll call this function here called showSolution, which will basically go through our solution one at a time and then call a print function so that we know which piece is at which location. Now I'm not going to tell you how I went about to find the solution. That's for you guys to try to figure out yourselves. So let's take a look at the header file. Inside of the header file, I define here a class object called piece, which has public and private sections. In the public section, I have a used flag. So as I go through trying to find a solution, what I'm going to do is basically take a piece and then mark it as used. Once I've marked it as used, then I can't use that same piece over again to find the solution. In other words, I can only ever use a piece once in the solution. I can't use the same piece multiple times. So that's what that Boolean variable is for. I have an enumeration here for top, right, bottom, and left. This is to designate the location of each of these individual symbols that we find on the pieces. So we saw that in the constructor we pass in these guys, and the order in which we pass them in designates whether they go on the top, the right, the bottom, or the left side. As for the symbols, we have the heart pointing outward, we have the heart pointing inward, we have the spade out, spade in, club out, club in, diamond out, diamond in. And you'll notice that the way that I've ordered these, they match up in such a way so that the middle one here, which I've labeled fits, is actually equal to 0, and all the other ones are the negative of the ones below. So for instance, diamond out is the value of -1, whereas diamond in is a value of 1. Club out would be -2, club in would be +2, and so on and so forth. So heart out is -4 and heart in is +4. And I specifically did this because it makes the computation to figure out whether a piece meshes in with another piece very easy to calculate. You can see here that if we try to take a club out piece and join it with anything other than a club in piece, it's not going to work because if we take this symbol and add it to this symbol, the value will not equal 0. And 0 basically represents that those two pieces mesh together perfectly and they interlock. So that's the way that I've defined them. And I also have this unknown symbol. That's just designated as the initial value that the constructor sets things to for the piece class. Down inside of the private section, I also create this structure called shape. And the shape is basically an array of 4 objects. Now, because in the constructor we pass in top, right, bottom, and left, each of these are symbols, and each of those symbols correspond to one of these values. Well, we have to correspond those somehow to this shape object so that we'll know, for instance, if we compare here at the location, top is 0, right is 1, bottom is 2, and left is 3. So that directly corresponds to the shapes here. There's also a print function which basically will print out the overall shape in textual forms so that as a human you can read and understand what that shape is supposed to represent. Other functions that are found inside of the piece class is we have the constructor, we have the print function, which will really, all it does is it goes through and iterates through all of the shapes that it's stored and use its print function to print out the results. And a very important function here is test match. So because test match is part of a piece object, we pass in a second piece object and we're basically trying to see whether these two pieces match together. If they do, then the value that gets returned here would be true to represent yes, they do match up, or false if they don't match up. You also need a location because of the way you pass in the pieces. You need to know, well, how are these pieces oriented? That's another sort of important thing to remember with this location. Each piece that you have has 4 edges, top, bottom, left, and right. However, as you're trying to find the solution, you don't know what orientation the piece is in. So you need to somehow store that in your class so that you do know, as you're trying to create a solution, which way is up. Finally, we have these 2 other functions, so show solution, which I already showed over here. It just iterates through all the pieces at the solution level and prints out the results. And another function that you're going to need is some sort of check fit function. So depending on the index that you're looking at and the piece that you're working with, check to see whether it fits. Well, that's what I did. You may end up coming up with your own solution on how to use this program to actually solve the problem. So hopefully this gave you a little bit of an insight as to how you could conceptually take the real objects, the real pieces, and enumerate them and represent them somehow in the computer so that you can get the computer to solve it. I'll be using this class in the next VMK to actually show you the solution. I'll also say that I've slightly modified this class. I've added a few functions and a few variables just to make things a little bit easier, but overall the structure is exactly the same as what I'm showing you here. Alright, so I hope you have fun trying to solve this puzzle, and we'll see you in the next VMK.